Hello everyone, myself Ketan Bhavsar, Assistant Professor in Engineering College, Ahmedabad. In today's session, in terms of embedded system, we discuss about serial communication. In previous session, we already discussed about different types of communication protocol. Like we discussed about serial communication, we discussed about the parallel communications, we discussed about the wireless communication. But now we discuss about the serial communication, and one of the most popular serial communication type, which is we are not considering at that time. So JTAG, USB, and the new one that today we see in this session. So in serial communication, we are talking about this particular type of protocol, which is a part of serial communication. So fly-by-wire. What exactly the meaning of fly-by-wire? Fly-by-wire was designed so that the pilot moves his control that provided electric inputs into a computer, and the computer that used the information from then use information from other inputs and then calculate the proper control changes. So basically, with help of the computer, you can provide the different types of changes in embedded devices. This command is transmitted by the wire to an actuator or an servo back to the wing, which moves the control surface. So basically, with help of the wire, we transmit the data to the computer, and with help of the computer, we can control the different types of peripherals in terms of embedded system. It can be a sensor, it can be an actuator, it can be a relay, it can be a motor, it can be anything. So basically, the fly-by-wire protocol is really working from the input side configuration that provides the different types of control mechanism. Now, why we are using the fly-by-wire and why the MSP 430 is use a fly-by-wire concept? See, the reason is very clear, because it provides the automatic stability system. In terms of that, it provides the stability to a specific input signal. Then how it provides the stability for a specific signal? So gyroscope is one of the best examples that provides the stability for a specific signal. Fly-by-wire control systems allow the aircraft computer to perform a task without a pilot inputs. So automatic stability system operates in this way. Gyroscope fitted with the sensor are mounted in the aircraft to sense the moment change in the pitch, roll, and a specific axis. And according to the movement, it will set a decision that what exactly the position of the aircraft is. So automatic stability system is play a main role when you have a large number of inputs and you want a stable output on each and every condition. Now you can see the block diagram or specific, we can say that automatic stability system. Then how you can provide the stability for the specific signal. So here you can see this particular diagram, that one reference signal that we are entered into the controller side, and we have one system. Now we are getting the data from the sensor. Now as per the data coming from the sensor side, we have to measure the error ratio, means your reference point and your sensor output. If we try to maintain the minimum error rate as much as possible, so, and according to the summation of error rate and the sensor input, it will send the signal to the controller, and controller will send the signal to a system, and system will work according to the controller signal. So here the sensor is play a main role, because you have to set one reference point. After set one reference point, sensor getting the data from the sensors, which is surrounded by the environment, and after getting the data from the sensor, it will send to a submission side, and it will measure the difference between the reference and sensor output and try to maintain the minimum error rate as much as possible. And according to that, controller send the signal to the system, and again we have to measure a specific system output and try to balance a system as much as possible. So automatic stability system is work on this particular situation, or we can say that it work on this particular concept. Sometimes it's also called as a PID based concept, right, to try to maintain the stability of the system. Now there are the two types of system in a fly-by-wire: analog system and digital system. See, right now we are generally focusing on the digital part only. But if you're talking about the analog portion, then whenever you want to work in sensor-based concept, see, as I already told you, there are the two types of sensors, analog and digital. Similarly, in analog side, there are some sensors, it can be calibrated and non-calibrated, right? So whenever you want to work in some analog sensor, like it can be a PT100, PT1000, thermistor, so you definitely have to go with analog system, right? So there are the two types of system, analog system and digital system. So this protocol is work in both the type of system, analog as well as digital. Now we're talking about the analog system. What is analog system? So the fly-by-wire replaces the hydromechanical or electrical mechanical flight control system with electric circuits. Definitely, if you're talking about a fly-by-wire, then it replaces the electromagnetic circuit, or we can say that the electromechanical part, and replace that part with the electronic circuit. So what exactly happens? If you reduce a mechanical portion, then definitely the performance, or we can say the efficiency of the system will increase day by day. In terms of a Moore's law that we already know, if you add number of transistors, then your system's performance became much more stable. So basically in analog circuit, we are not using any controller portion, right? But we can design some circuit with help of the analog ICs, with help of the op-amp based ICs, right? So here we are talking about an electronic circuit in terms of op-amp based circuit. The control mechanism in a clock pit now operates a signal transducer, which in turn generates the appropriate electronics command. So a transducer is generally convert one energy to the another way, means definitely we try to convert in terms of the electronic way, and that particular electronic signal is work as a command and try to maintain the circuit, or try to maintain the control mechanism of the signal, or we can say that try to maintain the control mechanism of the system as much as possible. But make sure that you have to take care about the error rate as less, or you can say that as small as possible. So in electronic circuit and controller, it play a main role. So that analog circuit will be calibrated by analog circuit, and that analog circuit is transmitted to, we can say that, a controller or a digital circuit. So these are the analog system, right? Fly-by-wire protocol is used in both the type of circuit, analog as well as digital, right? In terms of the analog side, you have to make sure that we are not using any controller, we are using the analog ICs, try to maintain the calibrate the signal. After getting the calibrated the signal, we send that the signal to the controller side, or we can send that to the digital circuit. Now what is digital circuit? A digital circuit, definitely we're talking about the digital ICs, we're talking about the microcontroller, we're talking about the processors, we're talking about the different types of stability circuits, right? So in digital system, a digital fly-by-wire flight control system is similar to its analog counterparts. Definitely it will work similarly as an analog circuit. The signal processing is done by digital computer, and the pilot literally can fly via computer, and it increases the flexibility of the flight control system. So with help of the computer mechanism, it tries to maintain the flexibility of the system, or we can say that for the circuit, as much as possible. So a digital computer can receive the input by the aircraft sensor. Aircraft sensor means we are talking about any type of digital sensors, right? Any type of the sensor that we are talking about. It can be a PIR, it can be a motion, it can be a fire sensor, or it can be a humidity sensor. Any type of digital sensor you can directly connect with the fly-by-wire circuit, and it will be controlled by the controller. Here we are talking about the computer mechanism, because in this session we discuss about the aircraft, and for that we are not using simple microcontroller. Definitely we have to go with the RTOS based concept, and because of that reason we are talking about the computer in this particular example. And this also increases the electronic stability, because the system is less dependent on the values. Definitely, if you're talking about the analog circuit, that we have a range of voltage, it starts from 0 to 5 volt, right? So basically we have a range of 0 to 5 volts. So it can be any value. It can be a 0.1, 0.2, 0.111, 0.0001. It can be any value, right? And if you move to the digital portion, then definitely it tries to reduce the complexity, because it have a range of only 0 to 1. But still, we can say that the digital circuit is not stable at all, and because of that reason, we are using the automatic stability circuits, because there are the billions and millions value between the zeros to 1. Right? Because of that reason, some of the circuit are using the quaternary mechanism. In terms of the quaternary mechanism, we divide the value in 4 parts from 0 to 1. Means it can be 0 to 0.25, from 25 to 0.5, 0.5 to 0.75, and then 0.75 to 1. So in terms of digital circuit, right now we are focusing on only 0 and 1, Because our microcontroller can understand only a digital or transistor level concept. It will not understand the quaternary logic, and for the quaternary we have to design all the circuit by scratch. Now advantages. See, every coin has a two sides. Find some of the advantage and some of disadvantage. Now we are using the fly-by-wire protocol or a serial communication protocol. There are some of the advantages that definitely it tries to reduce the mechanical contacts. And if you reduce the mechanical contact, then your system become much more compact or stable or reliable, we can say that. And that particular mechanical contact is replaced by the wires. Due to the eliminations of this mechanical contacts, we reduce initial noise ratio also. So the control system used in this type of far more intelligence than the convolution system. So basically to increase the intelligence in the system, we have to go with a fly-by-wire protocol. Now we're talking about few applications. Now what exactly the application of fly-by-wire? So basically fly-by-wire is one of the most popular type of protocol that are used in defense. Basically in the aircraft, in defense, in terms of military and civil services, they are also using the fly-by-wire controller, and it provides the stability in terms of automatic pilot control system. So satellite manufacturing is also using this particular fly-by-wire protocol, and also the several airlines, and we can say that the planet technology or aerial vehicles is also using a fly-by-wire protocol. So there are the number of applications, number of different advantages is there, and we're talking about a fly-by-wire protocol. So basically in serial communication we discuss about the different types of protocol, like we discuss about USB, we discuss about I2C, we discuss about the SPDIO, we discuss about SCL and SDO, and also we discuss about JTAG. So fly-by-wire is one of the most popular type of serial communication protocol that are using in right nowadays. MSP 430 is one of the best example that they are using the fly-by-wire controller from the Texas Instrument, and with detailed study in this particular fly-by-wire protocol, or we can say that the program in chapter number 7. So I hope that you are getting the idea about fly-by-wire protocol. Still, if you doubt, then you can feel free to contact me. So thank you for watching.